January 30th, 2024. USS Gravely, Red Sea. A Houthi anti-ship cruise missile screams toward the destroyer at 600 miles per hour, 1 mile from impact, 4 seconds to collision. Every other defensive system either missed, malfunctioned, or didn't have time. The standard missiles that should have intercepted at 15 miles, nothing. The evolved Sea Sparrow that should have engaged at 8 miles, nothing. The 5-inch deck gun that might have hit at 2 miles, nothing. 4 seconds. And then something moves. A white dome atop the superstructure rotates 40 degrees in half a second. A 6-barreled cannon elevates 15 degrees. Radar locks. Computer calculates. And without asking permission, without waiting for human authorization, without even alerting the crew what it's doing, the system fires. 75 tungsten rounds leave the barrels in 1.2 seconds, traveling at 3,600 feet per second, creating a wall of metal that the missile cannot evade because there is no room to evade and no time to maneuver. The missile disintegrates 300 meters from the ship. Debris splashes harmlessly into the Red Sea, and the white dome continues rotating, scanning for the next threat that might come from literally any direction because that's what it's designed to do. This is Phalanx, the close-in weapon system, the last line of defense when everything else fails. And the reason it works is the same reason it looks like R2-D2 from Star Wars, because when threats come from everywhere at speeds that make human reaction impossible, survival depends on a weapon that sees everything, tracks everything, and shoots everything, all while spinning in complete circles faster than human eyes can follow. Let me show you why 360-degree rotation changes defensive mathematics, how autonomous systems decide who lives and dies in seconds, and why the strangest-looking weapon on any warship is the one that matters most when you're 4 seconds from dying. The problem is geometry. Anti-ship missiles don't approach politely from the bow where main guns can engage them. They attack from whichever angle gives them the best chance of hitting. From the stern, where radar coverage is weakest. From the beam, where ships are widest and present maximum target. From high-altitude diving down. From sea-skimming altitude where radar horizon is 12 miles and detection time is seconds. And in coordinated attacks, they come from multiple directions simultaneously. One from the north, one from the south, one high, one low. Force defenders to choose which threat to engage first while others close unmolested. Traditional gun mounts have limited traverse, maybe 150 degrees of arc, fine for surface gunfire where targets are on the horizon and approach slowly, useless for missile defense where threats arrive from any bearing and closing at supersonic speeds. You position the gun toward the most likely threat axis. If attacks come from other directions, you're rotating the mount while the missile is already in terminal phase. By the time the gun aims where it needs to aim, the missile has impacted. That geometry problem is why traditional point defense failed repeatedly throughout naval history. Weapons that couldn't rotate fast enough, fire control that couldn't track from all angles, defensive systems optimized for the last war instead of the current threat. The 1967 sinking of the Israeli destroyer INS Eilat proved this brutally. Soviet-made Styx missiles approached from unexpected bearings. The ship's guns couldn't traverse fast enough. Limited fire arcs meant some threats were literally outside the defensive envelope. The destroyer sank with 47 killed. That incident shocked navies worldwide. If missiles could strike from any angle and guns couldn't rotate fast enough to engage them all, the entire concept of point defense needed rethinking. Ships needed weapons that didn't have blind spots, didn't require perfect positioning, didn't care which direction threats originated from. Phalanx solves geometry through complete spherical coverage, 360 degrees of rotation, 150 degrees of elevation. The weapon tracks from directly overhead to below the horizon, from dead ahead to directly astern. There is no blind spot, no angle of approach that places threats outside engagement envelope. If it's in the sky and threatening the ship, Phalanx can see it and shoot it, and the rotation speed is what makes it tactically devastating. The mount can traverse 360 degrees in under 2 seconds, elevate from -25 to +85 degrees in 1 second, while tracking targets moving at Mach 2. That's not mechanical movement, that's ballistic response. The mount reacts faster than humans can think, faster than pilots can maneuver, fast enough that by the time a missile realizes it's being tracked, tungsten rounds are already in flight toward it. The engineering required to make this work is genuinely extraordinary. The entire system weighs approximately 12,500 pounds. Radar domes, gun assembly, ammunition magazine, fire control computers, all mounted on a base that must rotate smoothly while maintaining target track accurate to milliradians. And it has to do this on a ship. Ships pitch and roll in seas. They maneuver during combat. The stable platform that artillery needs doesn't exist. Everything moves. Everything vibrates. The horizon tilts 10 degrees port, then 10 degrees starboard as the ship rolls and swells. Phalanx compensates automatically. Stabilization systems isolate the weapon mount from ship motion. As the deck tilts, the mount counter-rotates to maintain aim on target. The gun always points where the computer says it should, regardless of what the ship is doing. That stabilization happens in real time at millisecond intervals. Gyroscopes detect motion, computers calculate corrections, motors adjust mount position, all autonomously without human input or awareness. The crew knows Phalanx is engaging when they hear it firing, not before. The system makes decisions faster than humans can communicate them. The development timeline reveals how radical this concept was. In 1973, the first prototype mounted on USS King proved the basic concept worked. Traditional naval officers were skeptical. A weapon that aimed and fired itself, that made engagement decisions autonomously, that sounded like science fiction, not practical naval defense. But testing on USS Bigelow in 1977 silenced skeptics. The system intercepted every test target. It maintained function despite jamming, despite sea states, despite everything thrown at it. Reliability exceeded 95%, and it did everything automatically, faster than human operators could manage manually. Production began in 1978. By 1980, USS Coral Sea became the first ship fully equipped with operational Phalanx, and within 5 years, every major surface combatant in the U.S. Navy was getting the system installed. The autonomy is where 360-degree rotation becomes truly lethal. Phalanx operates in multiple modes. Manual, where operators control targeting. Semi-automatic, where operators authorize engagement. And fully automatic, where Phalanx does everything. In automatic mode, the system is sovereign. It detects threats, evaluates them, prioritizes based on speed, range, and trajectory, engages them, assesses whether kills are achieved, and does all of this without asking permission or waiting for humans. That autonomy is necessary because human reaction time is 0.25 seconds minimum. Add decision-making and coordination, and humans need 2 to 3 seconds minimum to respond to threats. A Mach 2 missile at 1 mile impacts in 4 seconds. If humans are in the decision loop, the missile hits before authorization to fire is given. Autonomy is not optional, it's mandatory for survival. And 360-degree coverage means Phalanx autonomously engages threats from any direction. A missile approaches from 90 degrees directly to starboard. Phalanx rotates, locks, fires. While that engagement is happening, a second missile appears at 270 degrees, directly to port. Traditional systems with limited traverse can't switch targets that quickly. They're committed to the first engagement. The second missile impacts while the gun is still tracking the first. Phalanx rotates 180 degrees in 1 second. Disengages from the first target, acquires the second, fires. Both threats engaged before either reaches the ship. That engagement flexibility means the system handles multiple threats from multiple vectors without hesitation or delay. Rotation speed eliminates the tactical problem of threats outside the fire arc. The threat prioritization algorithms are sophisticated beyond what most people realize. Phalanx doesn't just shoot at everything. It evaluates which threats matter most. A missile 2 miles away, closing at Mach 2 is higher priority than one 4 miles away at Mach 1. A missile on direct collision course is higher priority than one passing nearby. The system calculates time to impact for every detected threat, builds a queue, engages the most dangerous first, switches to the next when the first is destroyed or if it becomes lower priority than newly detected threats. All of this happens autonomously. The computer is making triage decisions about which threats to kill and in which order. No human has time to evaluate those decisions. The system must be trusted to prioritize correctly. And the 360-degree rotation means the system can execute those priorities regardless of threat geometry. If the highest priority target is behind the ship and a lower priority target is ahead, Phalanx rotates to engage the higher priority threat first. Geography doesn't constrain tactical decision making. The radar integration is what makes rotation meaningful. Phalanx carries two radars, a search radar that scans continuously in all directions, and a track radar that locks individual targets for engagement. The search radar sits atop the white dome everyone recognizes. It rotates constantly, sweeping 360 degrees multiple times per second. Anything airborne within range appears on that radar. The computer evaluates every contact. Is it closing? Is trajectory consistent with missile attack? Does speed match known threat profiles? All evaluated in milliseconds. Contacts that meet threat criteria get passed to track radar. Track radar is more focused, narrower beam, higher resolution. It locks the specific threat, tracking position, velocity, altitude. And here's what makes Phalanx unique. It tracks both the threat and the outgoing rounds. The system measures where its own bullets are going in real time. If rounds are missing left, the gun adjusts right. Missing high, adjust low. The feedback loop is instant. Fire, measure, correct, fire again. That closed loop fire control is why Phalanx has high kill probability despite firing at targets moving at Mach 2. The gun isn't trying to predict where the missile will be. It's shooting, seeing where rounds go, and correcting until rounds and missile occupy the same space. And the 360-degree rotation means this closed loop correction works regardless of target bearing. Threat from dead ahead, track and correct. Threat from behind, rotate 180 degrees and do the same. The geometry doesn't constrain the engagement. The Ku-band frequency the radar uses is specifically chosen for this mission. Higher frequency than typical naval radar, providing better resolution against small, fast-moving targets. The wavelength is short enough to generate precise tracking data on objects the size of missiles, but Ku-band has limitations. Rain and sea spray attenuate the signal. That's why Block 1B added the forward-looking infrared sensor. When radar struggles in poor weather, infrared sees thermal signatures that don't degrade in precipitation. The combination means Phalanx maintains effectiveness regardless of atmospheric conditions. Rain, use FLIR. Fog, use radar, both degraded, combine both sensors. The 360-degree rotation means whichever sensor is working can engage from any bearing. The ammunition is specifically designed for this mission. 20mm rounds with depleted uranium or tungsten penetrators surrounded by discarding sabot. Heavy metal cores for maximum kinetic energy, lightweight sabots that fall away after leaving the barrel. The penetrators travel at 3,600 feet per second. At that velocity, hitting the missile's body is sufficient. The kinetic energy alone punches through airframes. The missile doesn't need to detonate, it just needs to break apart, which happens when tungsten traveling 2,400 miles per hour hits aluminum traveling 1,500 miles per hour in the opposite direction. Modern Block 1B systems use enhanced lethality cartridges with larger, heavier penetrators, 50% more mass than original rounds. That extra mass translates to more kinetic energy, which means more reliable kills against hardened targets like missile warheads designed to survive near misses. The fire rate is variable, 3,000 or 4,500 rounds per minute depending on threat. Against slower targets, 3,000 is sufficient. Against supersonic sea skimmers, 4,500 ensures enough rounds in the engagement window. At 4,500 rounds per minute, that's 75 rounds per second. A 2-second burst puts 150 rounds into a cone of fire approximately 30 feet wide at typical engagement range. The missile has to fly through that cone, and nothing survives flying through 150 tungsten penetrators. The magazine holds 1,550 rounds. At 4,500 RPM, that's 20 seconds of continuous fire. But engagements happen in bursts of 1 to 3 seconds. Realistically, Phalanx can engage 15 to 20 targets before running dry. That magazine depth is deliberate. If you're firing Phalanx, outer defenses have already failed. You're facing leakers, multiple threats that penetrated missile defenses. The system needs capacity to engage everything that got through, and the 360-degree rotation means those 1,550 rounds can engage threats from any direction. You don't waste ammunition shooting at threats outside your arc of fire. Every round can potentially engage every threat. Reload procedures are practiced religiously. Ammunition comes in preloaded drums that mate to the gun assembly. 2 trained crew members can reload a Phalanx in under 10 minutes. That's critical. If the ship survives the first attack wave, it needs Phalanx ready for the second wave. And waves always come in multiples. Adversaries don't fire one missile and wait, they fire salvos. If the first salvo is defeated, another follows minutes later. Keeping Phalanx loaded is survival. The combat history proves the concept. USS Gravely, January 2024. First confirmed naval combat use of Phalanx against a real threat. The missile got within 1 mile. All other defenses either missed or didn't fire. Phalanx engaged and destroyed the threat. 4 seconds from impact. That's how close it was. Traditional defenses with limited traverse or slower reaction time would have failed. Phalanx succeeded because it could rotate to threat bearing and engage instantly. The post-engagement analysis revealed something sobering. The missile approached from an angle slightly abaft the beam, roughly 130 degrees off the bow. If Phalanx had limited traverse like older gun systems, that angle would have been outside the fire arc. The ship would have been hit, but Phalanx rotated 130 degrees from neutral position in 1.4 seconds. By the time the missile was within engagement range, the gun was already tracking it. The 360-degree capability meant geometry wasn't a factor. Only time mattered, and there was just enough time. And here's what makes that engagement terrifying from the attacker's perspective. The missile had no warning. Phalanx doesn't emit targeting radar until it fires. The missile's sensors detected nothing unusual, no lock-on warnings, no indication defensive systems were tracking. Then suddenly, 75 rounds are in the air, and the missile is disintegrating. The engagement happened faster than the missile's computer could register threat. That stealth until firing is tactical advantage. Missiles with countermeasures deploy them when they detect tracking radar, chaff, flares, evasive maneuvers. But you can't deploy countermeasures against a system that doesn't reveal itself until rounds are already launched. The psychological impact on the Gravely's crew was significant. Sailors on deck heard the distinctive brrrr-tee of the Gatling gun firing. They didn't know why until alerts sounded seconds later. The system had detected, engaged, and destroyed a threat before human awareness caught up. That's the reality of autonomous defense. Machines make life or death decisions at speeds humans cannot match. And in this case, the machine chose correctly. The ship survived because the system didn't wait for human authorization. The international adoption reflects confidence in the concept. United States, United Kingdom, Australia, Japan, Canada, Germany, Israel, South Korea. Over 890 systems deployed globally across navies that face missile threats. Every ship in the U.S. Navy carries Phalanx except the 3 Zumwalt-class destroyers, carriers, cruisers, destroyers, frigates, amphibious ships. If it deploys in contested waters, it has Phalanx, and many ships carry multiple units. Aircraft carriers have 3 or 4 Phalanx mounts positioned to provide overlapping coverage. No matter which direction threats approach, at least one Phalanx can engage. USS Nimitz has 4 Phalanx mounts, 1 forward, 1 aft, 2 amidships. Between them, they provide complete 360-degree coverage around the entire ship. Any threat from any bearing faces at least one Phalanx, often 2. That overlapping coverage through multiple 360-degree systems is layered defense at close range. First phalanx engages. If it misses or the missile fragments, second phalanx engages debris. The ship is defended from all angles by systems that collectively see everything. The land variant, called CRAM for counter-rocket, artillery, mortar, uses identical principles for base defense. Same 360-degree rotation. Same autonomous engagement. Same Gatling gun. Iraq and Afghanistan bases faced constant mortar and rocket attacks. Traditional air defense couldn't intercept projectiles following ballistic arcs at short range. CRAM could and did. The system deployed in 2005. By 2008, it had intercepted over 105 attacks. Mortars fired at bases were shot down in mid-flight. Rockets disintegrated before impact. Artillery shells destroyed at altitude. The 360-degree rotation was critical. Attacks came from any direction. Insurgents moved positions constantly. Traditional systems with limited traverse would have been useless. CRAM rotated to threat bearing regardless of where attacks originated. Soldiers on bases heard the distinctive brrrr-t sound of the Gatling gun firing, and they knew that whatever was inbound wasn't reaching them. The system was engaging autonomously, faster than humans could react. One forward operating base in Baghdad recorded 37 separate intercepts over 6 months. Mortars fired from different neighborhoods each time. CRAM rotated to engage each attack from whichever direction it originated. The 360-degree capability meant attackers gained no advantage from repositioning. The limitations are significant and understood. Effective range is 1.5 to 2 miles maximum. Against supersonic targets, engagement window is seconds. The system requires threats to be relatively close before engaging, and it's last-ditch defense. If phalanx fires, everything else has already failed. Standard missiles missed. Sea Sparrow missed. Electronic warfare didn't work. The layered defense collapsed, and phalanx is preventing catastrophic failure. That psychological burden on crews is real. Hearing phalanx fire means the ship nearly died. It means defenses were penetrated. It means the engagement was closer than anyone wanted. But it also means the system worked. When everything else failed, phalanx succeeded. And that success is directly tied to the 360-degree rotation that lets it engage regardless of threat bearing. The maintenance intensity is substantial. Each phalanx requires dedicated weapons engineers. The rotating assembly needs regular inspection. Bearings wear and require replacement. The radar systems need calibration. Ammunition drums need inspection for corrosion. 6 to 8 months of training produces a qualified phalanx technician. They learn electrical systems, mechanical systems, radar systems, ballistics, and computer systems. The complexity is significant because the system integrates multiple technologies into one platform. But that maintenance investment pays dividends. Availability rates for Block 1B systems exceed 75%. That means 3/4 of the time, when needed, phalanx is operational. For last-ditch defense, that reliability is acceptable, not perfect, but sufficient. The future. Development is incremental. Block 1B added forward-looking infrared sensors for surface targets, small boats, drones, helicopters. The gun that shoots down missiles also shoots surface threats. Block 2, under development, will have enhanced processing, better discrimination between threats and non-threats, improved ammunition efficiency, but the core concept remains unchanged. 360 degrees of rotation, autonomous operation, closed-loop fire control. The fundamentals that made phalanx effective in 1980 remain valid in 2026. Some research explores replacing the gun with directed energy weapons, lasers that rotate 360 degrees, engaging threats at light speed. But that's future speculation. Current phalanx works, and ships don't replace systems that work with systems that might work. The cost is substantial but justified. Each phalanx system costs $8 to $15 million depending on variant and integration. That's expensive for what amounts to a radar-guided machine gun. But the alternative is unacceptable. Losing ships because point defense couldn't rotate fast enough. Watching missiles impact because fire control needed human authorization. Accepting that some attack angles are undefendable. Phalanx prevents those failures. And at $15 million per system, that's 0.5% of a destroyer's cost. Spending 0.5% to dramatically increase ship survivability is obvious value. The training emphasizes hands-off operation. Crews learn to activate the system, monitor status, and troubleshoot malfunctions. They don't learn to aim it or fire it. The computer does that better and faster. That shift from manual operation to automated oversight is psychologically difficult for some operators. Traditional weapons require operator skill. Phalanx requires operator trust. Trust that the system will identify threats correctly. Trust that it won't fire at friendly aircraft. Trust that when it engages, targets die. That trust is earned through testing and operational success. Hundreds of test firings. The USS Gravely Intercept. Land-based CRAM successes. The system works. And when it works, crews trust it. The nickname R2D2 is affectionate, not derisive. Crews recognize that the distinctive white dome and barrel-shaped radome look like the Star Wars droid, and like R2D2, Phalanx is small, automated, and consistently saves everyone when situations deteriorate. Every sailor on Phalanx-equipped ships knows where the systems are mounted. They see them daily, and they sleep better knowing that if missiles penetrate outer defenses, those white domes will rotate, lock, and fire faster than threats can arrive. The naval launcher that rotates itself 360 degrees. For coverage isn't about the gun, it's about the geometry of survival. When threats come from any direction at any time and reaction time is measured in seconds, not minutes, the weapon that saves you is the one that sees everything and shoots everywhere without waiting for humans to catch up. TEV. 1,500 pounds, 20mm Gatling gun, 4,500 rounds per minute, 360 degrees of rotation in under 2 seconds, and completely autonomous operation that makes life or death decisions faster than humans can think. That's not a weapon. That's automated survival. And when the USS Gravely had 4 seconds before a missile hit, when every other defense had failed, when human reaction time was insufficient, that automated survival meant the difference between floating and sinking. The threats came from 130 degrees. Phalanx rotated from neutral to 130 in 1.4 seconds. Locked, fired, saved 300 sailors who never knew they were 4 seconds from dying. Because the launcher that rotates itself doesn't ask where threats are coming from. It doesn't care which direction attacks originate. It just rotates, locks, and fires from wherever it needs to fire from. 360 degrees means everywhere, and everywhere means nothing gets through. Not from ahead, not from behind, not from above, not from the sides. The mathematics are simple. Threats can come from any direction. Defenses must cover all directions. 360 degrees of rotation is the only geometry that solves the equation. The engineering is complex. The concept is simple. And simplicity is what survives when everything else is too complicated to work in 4 seconds. The strangest looking weapon on any warship, the one that looks like a droid, the one that spins in circles while ships pitch in swells, the one everyone calls R2D2 because that's exactly what it looks like. That strange weapon is the one that matters most when threats are seconds from impact and every other defense has failed, because strange works, and spinning works, and automated works, and when you have 4 seconds to live, the weapon that rotates itself 360 degrees to shoot threats from any direction is the only weapon that matters.